Hi everyone, in this video we'll be discussing the problem LCS of three strings. Basically in this problem you will be given three strings, the string A, the string B and the third string C, and your task is to find the longest subsequence that is common in all the three strings. What does this mean? So let us talk about a basic example. Suppose that I have a string that is A, B, C, D. Okay, let's say that is string 1. And let's say if I have another string st2 and let's say that string is basically P, then I have Q and then I have B and then I have got let's say something like E, F and then D. Okay, so if I'm talking only about two strings, so what is the longest common subsequence in both the strings? Subsequence is basically when you can skip some characters, right? Subarray is what? Subarray is a contiguous segment. Substring and subarrays are contiguous in nature, but in subsequence you can skip several characters or several positions. So you can see that the LCS, the longest common subsequence for both would be if I choose B and D from the first string as a subsequence, right? And then I choose B and D from the second string as a subsequence, right? So you can see that BD is the longest common subsequence of the two strings. Now same thing I have to do for three strings. So instead of two strings I'll be given three strings here. Okay, so basically there will be a lot of ways, because the thing is, suppose that you are at the ith character of the first string, you are at the jth character of the second string and you are at the kth character of the third string, right? Then you need to ensure that the ith character of the first string should be same as the jth character of the second string, and the jth character of the second string should be same as the kth character of the third string. Indirectly I mean that the ith, jth and kth characters should be same. If they are same, then you will say that your subsequence length would increase by 1, right? Otherwise what you can do is either you can move one step ahead in the first string, that is you can do I++ and keep the js and ks same, or what you can do is you can keep your I same, k same and move your j, right, by one index. Or what you can do is you can simply say that you can keep your I and js same and you can move your k by one index, right? So basically you can see that there will be a lot of possible choices, three possible choices, and out of those choices you will choose that particular choice which is going to give you the maximum possible answer, right? So basically why do we do so? So suppose if I am talking about only two strings, right? Suppose that I have st1 string and let's say it is like a, b, c, d, and let's say I have got st2 string, let's say it is something like a, then let's say I have P, then I have D, then I have got E. Okay, suppose if I've got something like this. So if you will see here, so if this is the ith index, right, and this is the jth index, I'm just showing the example for two strings, and then eventually this can be used for three strings as well. So you can see that if ith and jth will be same, then I will say that I'll increase the length by 1 and then I will do I++ as well as j++. So my I will move here, okay, and my j will move to P. Now since they are not same, so I will have options, right? If they are not same, then either I can do I+1 comma j, or I can do I comma j+1. Suppose that if I do what? If I do I+1, so here my I will move here. Now still if they are not same, suppose still I do I+1, so I would move here. Now if still they are not same, so suppose if I increase my j, my j moves here. Now you can see ith and jth would be same, so the length would be increased by 1, right? So that is why these combinations are required in such kind of problems. Okay, so in our case what would happen is if the ith character, jth character and the kth character of all the three strings are same, then in that case we will increase the length by 1 and we'll do I+1, j+1, k+1, that is we will move by one index in each of the three strings. Okay, if it is not same, then we'll have three choices. Either we can do I+1 comma j comma k, okay, or what I can do is I can do I comma j+1 comma k, right? So we can move in the second string and keep the first and the third as the same. Or the third choice would be that we can do what? We can call for I comma j comma k+1, right? And since this is recursive problem in nature, so we need to apply dynamic programming to it, because there will be a lot of overlapping sub problems lying here as well. Okay, so let us try and write the code for this particular problem and see how it will be implemented. Okay, so let's open the compiler here, right? And I will be given the length of the strings n, that is n1, n2 and n3. So what we will be doing initially is like we can simply call a return recursive function where we can pass 0 comma 0 comma 0, because initially we'll be at the 0th index of all the strings. Then we'll pass the string a, then we'll pass the string b, and then we'll pass the string c as well. And then I will also pass n1 comma n2 comma n3. That is the length of the respective strings. Right now I'm not taking dp, but like once we have written the code and once we get TLE in this code, then we will also write the dp approach. In dp approach we just have to take a dp array, nothing else, everything else would remain the same. So what we'll be doing here is basically in this part you can say that we'll have int recursion, right? And then you can say we'll have int I comma int j comma int k, okay? And then we will have a string, let's say ampersand a, then we'll have string ampersand b, that is the second string I'm passing here, okay? I'm passing it by reference in C++, ampersand c. So I'll have the 3 strings, and then after that what I will do is I'll have int n1 comma int n2 comma int n3, okay? And once I have these, so I need to check for the base cases. What will be the base case? Suppose that if either of the string gets exhausted, okay, then in that case what will happen? If either of the strings gets exhausted, then you will have nothing left for yourself, okay? Then you have to, like, if one of the 3 strings is getting exhausted and 2 other strings still have some characters remaining, so you'll get nothing in common, because if one string gets exhausted, right, if one string is not having any character remaining, then you cannot find any common characters, right? So in that case what we need to write is that if the I value is equal to n1, or it happens that the j value is equal to n2, or it happens that the k value is equal to n3. So if we exhaust, then we should simply return 0, that if either of the 3 strings is exhausted, then we'll get nothing else in common, okay? Otherwise what we will check is we'll check that if the a of I is equal to b of j, okay, and the b of j is equal to c of k. So basically if the ith character of like if ai is same as bj and bj is same as ck, so this means that ai and ck are also same. So if all the 3 characters are same, ith, jth and kth character of the respective strings are same, then we need to say that we'll return what? We'll return 1 plus recursion of what? I plus 1, okay, comma j plus 1 comma k plus 1, right? And we'll pass the string a comma b comma c, and we'll pass n1 comma n2 comma n3 here, right? If they are same, then we'll move ahead in by 1 step in all the 3 strings. Else what we will do is we'll have 3 choices. So choice 1 is that we can do what? In choice 1 we can call the recursion and we can move by 1 index in the first string. So we can do I plus 1 comma j comma k comma a comma b comma c. Then we can do what? n1 comma n2 comma n3 is what we can do here. Then after that int c2 will be what? It will call the recursion for I comma j plus 1 comma k comma a comma b comma c comma n1 comma n2 comma n3, okay? This is what we'll do. And then we can say that the choice 3 would be that we can call the recursion where we can keep the ith and the jth index as the same, and we can move by 1 index in the third string, okay? And then we'll pass a b c strings, and then we'll pass the lengths, that is n1 n2 and n3 here, right? After this we will choose the maximum, so we'll return max of the 3. So we'll return max of c1 comma c2, choice 2 comma choice 3, whichever is returning the maximum, because we want the length of the longest, right? So let us just try and compile this code on the samples and see if I have made any mistakes here or not, okay? So as of now you can see it is working fine on the samples. Obviously it will give a TLE, so let's see if it is giving a TLE, then our approach is correct, okay? So yes, you can see that we are getting a time limit exceeded error, right? So this means that now we need to apply dynamic programming to it, because they will be overlapping sub problems when you are calling recursion. So they will be overlapping sub problems, right? So basically for that what we need to do is we need to declare a 3D DP, okay? Because we have 3 dimensions changing I, j and k, so we'll have vector of vector int, okay? Then after that what we will do is let me close this, okay, 1 2 3 close. Then I'll declare a dp array, right? And then I will have the size n1 comma, then I will declare vector. So you in other languages also you can just declare a 3D array, okay? Then I will do vector of vector int, okay? And then I'll write n3 here, sorry, n2 here, and then vector int, and then n3, and then initially I'll mark my vector like this thing as -1, okay? Let me see if I have closed it properly or not. Okay, so I guess I'm closing everything properly. Okay, so let's put a colon here and let's pass the DP array here. So initially I'm passing the DP array here, right? And then what we will do is we will check here, right? What we will check is that if the DP of ijk is not equal to -1. So if this particular state is already calculated, then we'll not calculate it again and we'll directly return the value of DP of ijk here. Okay, otherwise what we will do is we will calculate it and store it and then return its value. Okay, so we'll say that the value will be what, this one, this much, right? And then we'll store it in DP of ijk so that we don't have to calculate it again. So let's just do one thing. Let's write it like this only, and here also let's write it like value only. Okay, so I will declare a value variable outside, let's say here. And then after that, before returning, what I will do is I'll store the DP of ijk is equal to this value so that I don't have to calculate this state again, and then we can simply return this value. So by this way, exponential calls will be reduced. Now let's try and see whether it is getting compiled properly or not. Obviously I have not passed the DP array, so I should do that. So I will pass the 3D DP array here. So vector int ampersand DP. So I'll pass the DP array here, and in the function calls also, let me just quickly pass the DP array. Okay, now once this is done, let's try and compile this. Okay, so this is getting outside. So yeah, now let's try and compile this up. So it's working on the samples. Hopefully it should work fine. Let's see what happens. So you can see that our code was able to pass all the test cases, and it's like it was able to pass all the test cases, right? And it is getting accepted. So the time complexity for my code would be cubic in nature, because in the worst case, it will be running for n1 into n2 into n3. That is the length of the 3 strings state. And since I have taken a 3D DP, so the space complexity would also be n1 into n2 into n3. So just in case if you have any doubts, then you can let me know in the comments. And if you have understood this problem and the approach clearly, please make sure to comment down understood in the chat, or you can give us a +1 in the chat. Thank you for watching this video, and bye bye guys, take care.